I'm going to take a look at some properties of exponents. So the first one I want to look at is called the product and quotient rule. And so the first rule is called the product rule. And so I just want to look at a couple examples before we develop the actual rule. So first, let's write this out as repeated multiplication. So x to the fifth really means x times x times x times x times x 5 times. And that's getting multiplied by x cubed, which I can represent as x times x times x. Well, multiplication is commutative. I can multiply this x times this x or vice versa. How many x's are being multiplied together? A total of 8 of them. So I could rewrite this as x to the 8th power. Well, 5 plus 3 is 8. So the general rule for the product rule is if these bases are the same, so a is the same or x is the same, you are allowed to take the exponents and add them together, n plus m, just like x plus or 5 plus 3 was 8. So the product rule says to multiply powers with the same base, you're going to add the exponents. And if you forget this rule, just write it out as repeated multiplication because that would be a great way to figure out the rule. The quotient rule we're going to write out in a similar way. So x to the fourth I could write out as x times x times x times x in the numerator and x times x times x in the denominator. Well, when you divide something by itself, it can cancel. So I really just have x left in the numerator, or x to the first power. 4 minus 3 is 1. If there was a 1 right there. So the general rule is if you're dividing and you've got the same base, you were allowed to subtract your exponents, n minus m. So the quotient rule says that to divide powers with the same base, subtract the exponent of the denominator from the exponent of the numerator. So let's do some examples together. So we're going to simplify each expression. So x to the 6th times x to the 8th is the product rule, so we're allowed to add together the exponents x to the 14th. What about when we multiply two different terms together? We want to multiply the 3 times the 5 because those are like terms, that's 15. And then x to the 1st times x to the 5th would become x to the 6th. So I would have 15x to the 6th. In the next one, 5 times 6 is 30, and m squared times m to the 4th, if I add those together, would be the 6th. So 30m to the 6th. These parentheses aren't really doing anything. They're separating, but we can multiply anything we want in each of the terms. So I'm going to cross them out as I multiply. 3 times 5 is 15. A cubed times a cubed would be a to the 6th. B to the 6th, b to the 4th would be b to the 10th. And c times c squared would be c cubed. Now we're going to do some division. So remember, when you're dividing, you're going to subtract the numerator power minus the denominator power. So 9 minus 4 will be x to the 5th. And on number 6, 12/8 I can reduce as a fraction. I can divide both of those by 4. So 12 divided by 4 would be 3. 8 divided by 4 would be 2. So I have 3 halves. And then I've got 5 on top and 2 on the bottom. 5 minus 2 would be n cubed. So 3 halves times n cubed. Let's see, 3 over 6 would give me the fraction 1/2. And then I've got m to the 7th. So I'm doing 7 minus 3 would be m to the 4th. So 1/2 m to the 4th, or m to the 4th divided by 2. In number 8, -8 divided by 2 would be -4. I have m to the 5th on top, m squared on the bottom, so that leaves me with m cubed. And then I have n to the 9th on top and n cubed on the bottom, so I have n to the 6th. And you could either write it all over 1, or there would just be no denominator to this problem. So this one was relatively short today, so you are just going to have to complete the 10 problems on the back as your guided practice for today. However, if you want to go on to the next set of problems, both sets of exponent properties are already in Google Classroom, so you could do that.